Today's class is about Unit 5 Special Functions. The topic is Evaluation of Definite Integrals using Beta and Gamma functions. Content: Beta and Gamma functions definitions, just we recall them, and evaluation of definite integrals using Beta and Gamma functions. Definition of Beta function: if m and n are positive numbers, then the beta function is defined by the integral of 0 to 1 x power m minus 1, 1 minus x whole power n minus 1 dx, and is denoted with beta of m comma n. So that is beta with respect to mn is integral of 0 to 1 x power m minus 1, 1 minus x whole power n minus 1 dx. The properties of beta function: beta of mn is always equal to beta of nm. Beta of mn is equal to integral of 0 to infinity y to the power of n minus 1 upon 1 plus y whole power m plus n dy. Beta of mn is integral of 0 to 1 x power m minus 1 plus x power n minus 1 upon 1 plus x whole power m plus n dx. Beta of mn is 2 into integral of 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. And last but not least, beta of mn is gamma of m into gamma of n upon gamma of n plus n. So it is the relation between beta and gamma function. So these are the properties or other transformations of beta function. Gamma function. Definition: if n is positive, then the gamma function is defined by the integral 0 to infinity e power minus x to the power of n minus 1 dx, and is denoted with gamma of n. So it is the symbol of gamma. So gamma of n is defined as gamma of n is integral of 0 to infinity e power minus x power n minus 1 dx. Properties: gamma of n is n minus 1 gamma of n minus 1. Gamma of n plus 1 is n gamma of n, which is equal to n factorial for any n positive integer. And also we will have gamma of n is gamma of n plus 1 by n. And we will have a definition, that is gamma of n by k power n is nothing but integral of 0 to infinity e power minus kx x to the power of n minus 1 dx. Gamma of 1 is 1. Gamma 2 1 factorial 1. Gamma 3 2 factorial 2. Gamma 4 3 factorial 6. Gamma half root pi. Gamma minus half minus 2 root pi. Gamma minus 1, gamma 0, gamma minus 2, gamma minus 3, and so on are not defined. Find the value of gamma half. So we know that the formula integral of 0 to pi by 2 sine power p theta cos power q theta d theta is gamma of p plus 1 by 2 into gamma of q plus 1 by 2 upon 2 into gamma of p plus q plus 2 by 2. So using this formula, just putting p equal to 0 and q equal to 0. So we will have integral of 0 to pi by 2 sine power 0 theta. Anything power 0 is 1. Cos power q0 is cos power 0 theta is 1. D theta is gamma half into gamma half upon 2 into gamma 1. Just we have to replace p equal to 0 and q equal to 0 in this formula. This formula proof is already we have taken in previous videos. Now integral of 1d theta is theta limits 0 to pi by 2. Gamma half into gamma half is gamma half whole square 1 by 2. 2 is reversed here, thus we will have half. Substituting upper limit and lower limit as 0, that is pi by 2 is half into gamma half whole square, which implies that gamma half whole square is pi. Hence we will have gamma half is root pi. So simple proof, just we have to remember this formula. putting p equal to 0 and q equal to 0. Another example, compute gamma minus half and gamma minus 3 by 2. We have gamma of n into gamma of 1 minus n is pi by sine n pi. We have already proved this in previous videos. Gamma of n into gamma of 1 minus n is pi by sine n pi. Now putting n equal to minus half for first value in this equation, that is gamma minus half into gamma of 1 minus minus 1 by 2. Minus into minus is plus, that is gamma of 3 by 2 is equal to pi by sine of n. But what is n here? Minus half. So sine of minus half pi. But we know that sine of minus theta is a minus sine theta. That is minus sine pi by 2. But what is the value of sine pi by 2? 1. So pi by minus 1 is a minus pi. So it is the value of gamma minus half into gamma 3 by 2. So gamma minus half is minus 3 pi by gamma of 3 by 2. But gamma of 3 by 2, it is look like gamma of n plus 1. But what is gamma of n plus 1? N gamma of n. So 3 by 2 can be written as 1 by 2 plus 1. So that 1 by 2 gamma of 1 by 2. But what is the value of gamma half? So gamma half value is root pi. Just putting root pi, pi by root pi is root pi. The fraction is reversed here, that is minus 2 root pi. So hence the required value of gamma minus half is minus 2 root pi. Now another, for this we have to put n equal to minus 3 by 2. So we will have gamma of n into gamma 1 minus n is pi by sine n pi. Just we have to replace n as minus 3 by 2 in this formula. So gamma minus 3 by 2 into gamma of 1 minus of minus 3 by 2. But 1 minus of minus 3 by 2 is 1 plus 3 by 2. But 1 plus 3 by 2 is 5 by 2. Pi by sine of n. But what is n here? Minus 3 by 2. So sine of minus 3 by 2 pi. But sine of minus theta is minus sine theta. That is minus pi by sine 3 pi by 2. But sine 3 pi by 2 is minus 1. So clearly minus minus get cancelled, that is pi. So it is the value of gamma of minus 3 by 2 into gamma of 5 by 2 is pi. Just let it gamma of 5 by 2 on the right hand side. Then gamma of 5 by 2 will be divided with pi. So that is gamma of minus 3 by 2 is pi by gamma of 5 by 2. But 5 by 2 can be written as 3 by 2 plus 1. So it is look like gamma of n plus 1. But what is gamma of n plus 1? N gamma of n. That is a 3 by 2 gamma of 3 by 2. But 3 by 2 can be written as 1 by 2 plus 1. So gamma half plus 1 is half gamma half. But what is the value of gamma half? Root pi. So that is a pi by 3 by 2 into 1 by 2 into root pi. So gamma 5 by 2 is 3 by 2, 1 by 2 root pi. For example, if there is gamma 7 by 2, then it will be 5 by 2, 3 by 2, 1 by 2 root pi. Suppose there is gamma 9 by 2, then it will be 7 by 2, 5 by 2, 3 by 2, 1 by 2 root pi. Now simplifying, pi by root pi is root pi. 2 into 2, 4. 3 by 4, the fraction is reversed here, that is a 4 by 3 root pi. So it is the required value of gamma of minus 3 by 2. So using this formula, we can evaluate many of gamma values for negative real numbers. Evaluate integral 0 to infinity dx by 1 plus x power 4. Putting x power 4 equal to y. Now differentiating on both sides, x power 4 derivative is a 4x cube, dx is dy. So which implies that dx is dy by 4x cube, which is obtained by just by dividing with 4x cube. Substituting these values in above integral, the above integral becomes integral of 0 to infinity dx, but dx is dy by 4x cube. But what is x here? X is y power 1 by 4, which is obtained by taking 1 by 4 on both sides. Power 1 by 4 on both sides, we will have x is y power 1 by 4. So substituting, we will have dy by 4 into y power 1 by 4 whole cube, that is y power 3 by 4. If it comes to numerator, then it will be y power minus 3 by 4 by 1 plus x power 4. But what is x power 4 here? Y. So clearly here, the independent variable x is changed to or transformed to y. The total integrand function now is in terms of y. 1 by 4, just take it out. Integral 0 to infinity. Now negative 3 by 4 can be written as 1 by 4 minus 1. Now it is look like integral of 0 to infinity x to the power of n minus 1 by 1 plus x dx is nothing but pi by sine n pi. Comparing with this formula, the above integral value becomes 1 by 4 integral of 0 to infinity y to the power of 1 by 4 minus 1 by 1 plus y dy. So here n takes place 1 by 4. Thus it will becomes 1 by 4 constant pi by sine n pi. But what is n here? N is 1 by 4, that is a sine of pi. 1 by 4 into pi is a sine of pi by 4. But what is the value of sine pi by 4? Sine 45 degrees, 1 by root 2. That is 1 by 4 into pi whole upon 1 by root 2. The fraction is reversed. So thus we will have pi into root 2 by 4. So it is the required value of the given integral. So simple, just we have to remember this formula. The formula is here integral 0 to infinity x power n minus 1 by 1 plus x dx is pi by sine n pi. Another example, show that integral 0 to pi by 2 tan power n theta d theta is half into pi secant of half n pi. So we have integral of 0 to pi by 2 tan power n theta d theta. Tan power n theta can be written as sin power n theta by cos power n theta. But 1 by cos power n theta is cos power minus n theta. So it can be written as cos theta whole to the power of minus n. Now we will have a formula, that is integral 0 to pi by 2 sin power n theta cos power n theta d theta is gamma of m plus 1 by 2 into gamma of n plus 1 by 2 upon 2 into gamma of m plus n plus 2 by 2. So here what is m here? N, and what is n here? Minus n. So replacing these values in this formula, the above integral becomes gamma of half into n plus 1, gamma of half into minus n plus 1 upon 2 into gamma of n minus n plus 2 by 2. So clearly here n get cancelled, 2 by 2 is 1, but gamma 1 value is 1. So gamma of n plus 1 by 2 into gamma of 1 minus of n plus 1 by 2 whole upon 2 into gamma of 1. So integral 0 to pi by 2 tan power n theta d theta is half into pi by sine half into n plus 1 into pi, because we will have a formula, that is gamma of n into gamma of 1 minus n is a pi by sine n pi. Just replacing the value of n here. That is, what is n here? N plus 1 by 2. Now that is half into pi constant, that is a pi by 2. 1 by sine of n plus 1 into pi by 2 is a cosecant of n plus 1 into pi by 2, because cosecant is the reciprocal of sine. So 1 by sine is a cosecant. So thus we will have half into pi cosecant of, just multiply with pi. So we, and 1 by 2 we will have n pi by 2 plus pi by 2. Multiplying with pi by 2 we will have pi by 2 plus n pi by 2. Don't forget 1 by sine is a cosecant. So it is the required value of integral 0 to pi by 2 tan power n theta d theta. So thus we will have cosecant of pi by 2 plus n pi by 2 is secant of n pi by 2, because the cosecant of pi by 2 plus theta is secant theta. So half into pi into secant of n pi by 2. So hence proved. Example, show that integral 0 to pi by 2 root of tan theta d theta is half into gamma of 3 by 4 into gamma of 1 by 4 is 2 into integral of 0 to infinity x square dx upon 1 plus x power 4. We have integral 0 to pi by 2 root of tan theta d theta. But root of tan theta can be written as root of sine theta by root of cos theta. But root of sine theta means sine power 1 by 2 theta by root of cos theta. That is, root of cos theta means cos power 1 by 2 theta. If it comes to numerator, it will be cos power minus 1 by 2 theta. Now it is look like integral 0 to pi by 2 sine power n theta cos power n theta d theta. So we will have a formula, that is integral 0 to pi by 2 sine power n theta cos power n theta d theta is gamma of m plus 1 by 2 into gamma of n plus 1 by 2 upon 2 into gamma of m plus n plus 2 by 2. So replacing m value and n value. So what is m here? Half, and n is negative half. So replacing these values in this formula and then simplifying. So we will have gamma of 3 by 4 into gamma of 1 by 4 by 2 into gamma of 1. But what is the value of gamma of 1? 1. So clearly the first proof is over here, that is half into gamma of 3 by 4 into gamma of 1 by 4. Now to prove the given statement, it is enough to prove integral 0 to pi by 2 root of tan theta d theta or half into gamma of 3 by 4 into gamma 1 by 4 is 2 into integral of 0 to infinity x square upon 1 plus x power 4 dx. So for this, gamma of 3 by 4 into gamma 1 by 4 can be written as beta of 3 by 4 comma 1 by 4, because gamma of 3 by 4 into gamma of 1 by 4 can be written as gamma 3 by 4 into gamma 1 by 4 upon gamma of 3 by 4 plus 1 by 4. But what is the 3 by 4 plus 1 by 4? 1. That is gamma 1 is 1. So thus we can write half into beta of 3 by 4 comma 1 by 4, because we will have beta of mn is gamma of m into gamma of n upon gamma of m plus n. M is here 3 by 4 and n is here 1 by 4. So 3 by 4 plus 1 by 4 is 1, gamma 1 is 1. So clearly this expression can be written as beta of 3 by 4 1 by 4. But we will have a formula, that is beta of mn is integral 0 to infinity y to the power of m minus 1 upon 1 plus y whole power m plus n dy. So just replacing m here, that is 3 by 4. Now putting y as x power 4, so that dy becomes 4x cube dx. And we will have same limits. So that is half into integral 0 to infinity y power 3 by 4 minus 1. But what is the 3 by 4 minus 1? Minus 1 by 4. So we will have y as x power 4. X power 4 whole to the power of minus 1 by 4. So clearly 4 get cancelled. So we will have x power minus 1. And dy is 4x cube dx. 1 plus y. But what is the value of y here? X power 4. So thus we will have x cube into x power minus 1 is x square by 1 plus x power 4 dx. So clearly proved. So just we have to remember the formulas. That is beta of mn is gamma of m into gamma of n by gamma of m plus n. And beta of mn is integral 0 to infinity y to the power of m minus 1 upon 1 plus y whole power m plus n dy. We can take n also here. Another example, show that beta of mn is beta of m plus 1 comma n plus beta of m comma n plus 1. So we have just take right hand side here. What is right hand side? Beta of m plus 1 comma n plus beta of m comma n plus 1. But beta of m plus 1 comma n is gamma of m plus 1 into gamma of n upon gamma of m plus 1 plus n. Because we will have a formula, that is relation between beta and gamma function. is beta of m comma n is gamma of m into gamma of n upon gamma of m plus n. Similarly, we can expand this beta function also. It is gamma of m into gamma of n plus 1 upon gamma of m plus n plus 1. Now, gamma of m plus 1 is m gamma of m. Gamma of m plus n plus 1 is m plus n gamma of m plus n. Gamma of n plus 1 is n gamma of n. Gamma of m plus n plus 1 is m plus n gamma of m plus n. Now taking out the common as gamma of m into gamma of n by gamma of m plus n. The remaining term in first term is m by m plus n. The remaining term in second term is n by m plus n. Now gamma of m into gamma of n by gamma of m plus n is nothing but beta of mn. Here LCM is m plus n. On numerator we will have m plus n. Clearly both m plus n or get cancelled. So it is required RHS, thus we will get LHS. So what is LHS here? Beta of Mn. Just we have to know about the relation between beta and gamma function. The relation is beta of Mn is gamma of m into gamma of n by gamma of m plus n. Prove that integral 0 to pi by 2 d theta by root of sine theta into integral 0 to pi by 2 root of sine theta d theta is pi. Solution. Consider first integral, that is integral 0 to pi by 2 d theta by root of sine theta. But root of sine theta can be written as sine theta whole power minus half. For our convenience, we can write cos power 0 theta because cos power 0 theta is 1. X power 0 is 1. Now it is look like integral 0 to pi by 2 sine power m theta into cos power n theta d theta. What is m here? Minus half and n is 0. So we will have a formula integral 0 to pi by 2 sine power m theta cos power n theta d theta is gamma of m plus 1 by 2 into gamma of n plus 1 by 2 upon 2 into gamma of m plus n plus 2 by 2. Just here we have to replace here m as minus half and n as 0. So on simplifying we will get gamma of 1 by 4 into gamma 1 by 2 by 2 into gamma of 3 by 4. So it is the required value of the first definite integral. Now computing second definite integral same as. So and second integral root of sine theta means sine power 1 by 2 theta. For our convenience we can write cos power 0 theta because the comparison is easy. That is compared with integral 0 to pi by 2 sine power m theta cos power n theta d theta. What is m here? Half and n is 0. So we will have a formula gamma of m plus 1 by 2 into gamma of n plus 1 by 2 upon 2 into gamma of m plus n plus 2 by 2. So using the formula, just replacing m and n values and simplifying, we will have gamma of 3 by 4 into gamma 1 by 2 upon 2 into gamma of 5 by 4. So let it be equation number 2. Just multiplying 1 and 2. So multiplying first one and second one. So clearly here gamma half into gamma half is gamma half whole square and gamma 3 by 4 get cancelled. So gamma 1 by 4 gamma half is root pi. So root pi into root pi. 2 into 2 4 and we will have gamma 5 by 4. This can be written as 5 by 4 can be written as 1 by 4 plus 1. But what is the value of gamma of n plus 1? N gamma of n. That is 1 by 4 gamma of 1 by 4. So 4 get cancelled here and gamma 1 by 4 gamma 1 by 4 is also get cancelled. But root pi into root pi is root pi whole square, that is a square and root get cancelled. So we will have pi. So it is the required value. Hence proved. Next problem. State and prove the relation between beta and gamma functions. The statement is the relation between beta and gamma function is beta of mn is gamma of m into gamma of n by gamma of m plus n. The proof is very important. By the definition of gamma function, we will have gamma of m is integral 0 to infinity e power minus t power m minus 1 dt. So here dt is missing, just write down. Now this can be solved by putting t equal to some x square. Now differentiating on both sides, we will have dt is 2x dx, and changing the limits. When t equal to 0, x is clearly we will have 0, and when t equal to infinity, x is root infinity, that is infinity. Same limits are obtained. Thus the gamma of m becomes 2 into integral 0 to infinity e power minus x square x to the power of 2m minus 1 dx. Similarly, we can write gamma of n also, which is obtained just by replacing m equal to n. Now taking the product of these two, because we have to show beta of mn is gamma of m into gamma of m plus n. For this, we have to consider gamma of m into gamma of n. Clearly, 2 into 2 is 4. Both the integrals are multiplied here. Together, we have to take as a double integral. So since the limits of the integration are constants, so we can write it as the double integral, that is a 0 to infinity, 0 to infinity, e power minus of x square plus y square, x to the power of 2n minus 1, y to the power of 2n minus 1, order is dx dy. Let it be equation number 3. Now we can use a change of variable concept in double integrals. Now changing into polar coordinates, we will have polar coordinate equations, that is x is r cos theta, y is r sin theta, dx dy is r d theta dr, to cover the region in equation 3, which is entirely lies on first quadrant. Here r varies from 0 to infinity and theta varies as 0 to pi by 2. Thus above equation number 3 becomes gamma of m into gamma of n is 4 into integral limits becomes 0 to infinity and 0 to pi by 2. First one is r limits and second one is theta limits. The integrand function becomes like this. So here we have to replace x square plus y square as r square, because x is r cos theta and y is r sin theta. That is r square. R square is nothing but x square plus y square. So and dx dy is r d theta dr. Now this double integral can be splitted as like this. So let it be equation number 4. Now the first value is nothing but beta of mn, but the second value, so what is the second value here? It is nothing but gamma of m plus n. So second value is gamma of m plus n, because so we will have gamma of m. So what is gamma of m here? 2 into integral 0 to infinity e power minus x square into x to the power of 2m minus 1 dx. In this, just we have to replace m with m plus n and x with r. So it is the value of e power minus r square, r power 2 into m plus n minus 1 dr is gamma of m plus n. And first value is nothing but well-known value, that is beta of mn. So what is beta of mn? 2 into integral of 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. Replacing these values in equation 4. So thus we will have the product of gamma of m into gamma of n is beta of mn into gamma of m plus n, which implies that the required proof, that is beta of mn is gamma of m into gamma of n by gamma of m plus n. So which is extremely very useful for evaluating the definite integrals in terms of gamma functions. So it is the information about evaluating the definite integrals using beta and gamma functions and the relation between beta and gamma function. For any queries, please contact. Thank you.